Good morning. So we're going to be covering quadratic functions today. Everything we cover should pretty much be some sort of review with maybe a couple little new things sprinkled in. So a quadratic is any equation written of the form ax squared plus bx plus c. The x squared is unique to quadratics. That's what makes it a quadratic. Okay, so when I have the graph of a quadratic, it's going to be a parabola that either opens up or down. Okay, so when we talk about the equation of a quadratic, it can be written in three forms. The first form is standard or vertex form. And this is y minus k equals a times x minus h squared, where hk is the vertex of your parabola. So very similar to when we did our circle equation. The second form is intercept or factored form. And this is y equals a times x minus r1 times x minus r2, where r1, r2 are our x-intercepts. So these are the places where our graph crosses the x-axis. And then we have our general form, which is the expanded y equals ax squared plus bx plus c, where c is our y-intercept. Because when I plug in 0 for x, everything goes away except for that constant term. So for each of these, there is some information that we can talk about. So for the first one, or the first piece of information, is if that a value, so that coefficient at the very front of each of these forms, is less than 0, then our parabola opens down. Like a frown is how I call it. If that a value is greater than 0 then, so if it's positive, our parabola opens up like a cup. So using this information, we can do a lot with quadratics. The first thing we're going to do is we are going to go ahead and find the vertex from these different forms. We're going to start with standard or vertex form. Vertex form is y minus k equals a times x minus h squared. The kind of cool thing about vertex form is it literally gives me the coordinates of my vertex without having to do any work. So my x coordinate is the number that's attached to x, take its opposite sign, so that'll be h. And then my y coordinate is the number that's attached to y, just take its opposite sign. So h comma k then would be my vertex from vertex standard, from vertex form. So then what about from intercept form? Remember, intercept form is y equals x minus r1 times x minus r2, where r1 and r2 are our x-intercepts, so places where graph crosses the x-axis. Our vertex then, the x-coordinate is going to be those x-intercepts added together, divided by 2, so the average of them. Our k then, so our y-coordinate, is going to be that number that we get for h, plugged back in to the function and solved. From general form, which is y equals ax squared plus bx plus c. Our x-coordinate h is equal to negative b over 2a. Our y-coordinate k then is equal to the function with that number plugged back in and solved. So that negative b over 2a, I would plug it back in for the variable x, and I would solve it out, and whatever answer I got would be the y-coordinate of my vertex. So let's go ahead and do a couple examples. And for each of these, I would like to find the vertex. So the first example is y equals 2x squared minus 6x plus 4. This is a general form for a quadratic. So I'm going to be using the negative b over 2a to find my x-coordinate, Negative of negative 6 is a positive 6. 2 times a is 4. This reduces to 3/2. So this is the h, or the x-coordinate, of my vertex. My y-coordinate then is my function, so that 2x squared minus 6x plus 4, solved at that 3/2. So I'm going to go ahead and plug in 3/2 for x. I get 2 times 3/2 squared minus 6 times 3/2 plus 4. I go ahead and start solving this out. I have to square the 3/2 first, and it becomes 9/4. Minus 6 times 3 is 18, divided by 2 is 9, plus 4. I recognize that this 2 is going to cancel out 2 from my denominator there, which leaves me 9/2 minus 9 plus 4. I can't put numbers together unless they have the same denominator. So I'm going to change minus 9 into minus 18 over 2, and plus 4 into 8 over 2. 9 minus 18 is a negative 9, plus 8 is a negative 1. So my y value then is negative 1/2, which means my vertex is the point 3/2, negative 1/2. We can go ahead and do another one. This one is y equals negative 2 over 9 times the quantity x minus 2 squared plus 3. Well, if you had subtracted that 3 over, this would look exactly like vertex form. And I know for vertex form, I don't have to do any work to find the vertex because it's just going to be the numbers attached to my x and my y with the opposite sign. So my vertex here, my x-coordinate is a positive 2, my y-coordinate is a positive 3, and I'm done. The third example we're going to do is an equation given to us in intercept or factored form, depending on how you want to look at it. My goal then is to find the vertex. Well, we already talked about this. The h value, which is our x-coordinate, is equal to my 2 x-intercepts divided by 2 when they're added together. So again, I use the opposite sign. So I have a positive 7 and a negative 4 being added together and then divided by 2. 7 minus 4 is 3, divided by 2 is 3/2. I go ahead and I take that 3/2 then, and I'm going to plug it in here to find the y-coordinate of my vertex. Okay, so from here I'm just going to start simplifying. 1.5 minus 7 is going to be a negative 5.5. I can go ahead and change that into negative 11/2. Then I have 1.5 and 4, which equals a positive 5.5. So this one's going to be a positive 11/2. I go ahead and I multiply them together and I get y equals 3 times. Well, we multiply straight across. So this is negative 121 over 4. And then I multiply the 3 in. And I get negative 363 over 4. So my vertex is 3 halves, negative 363 over 4. Okay, so that was all just finding the vertex from the different forms. Now we're going to start talking about what the graph tells us and what our vertex actually tells us. So we already covered that if I have an a value less than 0, my parabola opens down like a frown, right? If I have a parabola that opens down then, my vertex occurs at the highest point on that graph. Okay, because your vertex is always the highest or the lowest point. If my vertex is the highest point, we say that this function will have a maximum value because that is the highest point on my graph. If my a value is positive and my parabola opens up, my vertex then will be the lowest point on the graph, which means that this function or this equation would have a minimum value. We always identify our maximums and our minimums by the y value of that point. Okay, so it's always going to be the y value of the vertex. Let's see how much time's left. Okay. So what we're going to do now is we're just going to do a little bit of practice with these equations till we get a little more comfortable with them. So the first one is I want to find the standard or the vertex equation for a parabola that has a specific vertex which here is 4, negative 7, and an x-intercept of a negative 4. So I know standard form is going to be y minus k equals a times x minus h squared. The good news is I know some of this information already. I know that my h value is 4 and my k value is a negative 7. So this is going to become y minus a negative 7 becomes y plus 7 equals a times x minus my x value of 4. I'm not finished with standard form yet though because I haven't identified my a value. So that's where the second point comes in handy. If my second point is that I have an x-intercept of negative 4, that means its point is negative 4, 0. Just like we do when we are trying to find like the slope of something or trying to find a matching y, I'm just going to plug in negative 4 for x and 0 for y and find out what that a has to be. So I'm going to have 0 plus 7 equals a times negative 4 minus 4 squared. Well, I work it out. 0 plus 7 is just 7. Negative 4 plus a negative 4 is negative 8. I go ahead and I square that, and I get 7 equals 64a. Divide each side by 64. And I get that my a value is 7 over 64. So now I can take that and I can plug it back into this general form equation that I started. So I have, or standard form, sorry, y plus 7 equals 7 over 64 times x minus 4 squared. And there I have my vertex or standard form equation. So the rest of the notes will be on the next video.